Hello everyone, welcome back. In this video, we are going to see how to ask question over large database using AI. Have you ever asked AI a question like list all customer from Brazil? Here Brazil, I just give a typo and got back no data found. Because the classic AI fail here. Really what happened behind the scene? The AI didn't understand your database, it didn't know which table to look at, and worse, it couldn't even spell check the name Brazil. At this end of this video, you will learn how to handle large database, what are the real world problems, and what is the Langchain approach and the MCP approach, and demo using the Langchain. Let's start with the real world problems. Database have many tables and columns. Some columns have thousands of unique values, and the AI model can't handle all that info into a one prompt. So this leads to an invalid SQL or the missing joins. Even these simple questions fail to answer. So at the end of our query where the AI chat gets fed up and the result will get as no data found. So then what is the basic approach we do? Dump all schema and all values into every prompt. This approach exceeds model token limits and also this leads to missing joins, misspelled inputs not recognized and overloaded irrelevant prompt. The result no data found. So how to solve it? We built a smart LangChain pipeline that fixes this with 4 key steps. 1. Understand the user question. We use Gemini or GPT to extract the question intent. 2. Select only the relevant table. Instead of showing every table, we bind a tool and let the model pick just what it needs. 3. Handle misspelling. Using FAISS and OpenAI embedding, we search a vector DB of artists and album names. So even with the typo, Brazil maps to Brazil. Smart autocomplete for real world data. The fourth step is generate valid SQL. Now we feed only the relevant tables and feature values to the SQL generator. So this gives a correct result. In the normal approach, we have given a misspelled word for Alanis Morissette and got no data found. But using our LangChain approach, we got the result for the misspelled word Alanis Morissette. The another approach is using MCP. You can skip this entire manual chain entirely using model context protocol. MCP connects to database directly to the model. It decides what context it needs, pull it dynamically and answer the question just like magic. We have seen this MCP in our previous video, so this demo is only using LangChain. There are some difference we'll see at the end. Let's welcome to the demo part. First, I have downloaded some sample databases for SQLite. I have used a Chinook database file. The Chinook database was created as an alternative to the Northwind database. It acts as a sample database file. Just download the file and connect to the SQLite and query the table from the file. So it will be easy to have some tables and database in our local. I have given this link in our YouTube description. Just check it out. Next, from terminal, connecting to the SQLite 3, I just reading the downloaded Chinook sample database file. After reading the Chinook database and just querying some tables. Before explaining the code, let me run it first. This UI is developed on Streamlight. Here, first it loads all the DB from SQLite 3. So these are the list of queries we are going to execute. Let execute what are the top 5 longest songs by duration. This executes top 5 longest song. So I'm just verifying the results in the SQLite terminal. Next, I'm executing the query. What are all the albums by Queen? So it gives top 3 results. The next query I'm going to give with some typo. So what are the genres of Alanis Morissette song? Here we have typo in the Alanis Morissette, that is ALANIS, instead of that I have given as ELENIS. And it's correctly querying the results because we have implemented the vector embedding. Next, just I am verifying with the correct version of Alanis Morissette. I am getting the same result of our previous query. This is the implemented code for the shown demo. First libraries and setup, then followed by secure API key input for Google and OpenAI API keys. Next, connecting to the SQLite DB, then tool calling for table category selection. And then gathering proper noun from DB and embed using vector embeddings. Then we have given a template for prompt for SQL generation. Finally, using LangChain, we are chaining the table selection plus retriever plus SQL generator. And finally, Streamlight launch. That's it. Our code is ready and we can ready to launch our code. Check this entire code in my GitHub link and you can find it in this description. This problem can be addressed using both Langchain and Model Context Protocol. If you are looking for more control over prompt design, tool calling, or fine tuning your pipeline, then Langchain approach is a great fit. That's all for this video. If you found this helpful, please give it a like and subscribe to my channel for more tech content. See you in the next video with another exciting topic. Until then, bye and take care.